Laser World of Photonics, I'm at the booth of Finetech with Melanie Schmidt. We have seen for the first time that companies in the automated assembly of photonic devices are making a really big announcement at Laser World of Photonics. Melanie, what's new at Finetech?
Well, there are a lot of things that are new to Finetech and at Finetech. And we are very, very happy to be able to present our latest FINEPLACER technology here at the show with live demos, with live demonstrations for our customers, for potential new customers. And we are very excited about that.
We're all excited. It's Laser World of Photonics. How can we be excited? But when it comes to the passive alignment of Finetech, what are the biggest trends that you're seeing in the market and how are you answering them?
Okay, so I think there are a lot of new inquiries coming up with more complex products, more complex designs and more complex processes. And I think this is exactly what we can do, what we are really experts in. And this is why you should come to Finetech and talk to us. When it comes to Finetech, the debate in the industry is still passive versus active alignment. You have vetted for the passive alignment and you have proved that you can go from 0.3 to 2 microns already. Yeah. What is now the new thing that you want to push? I don't know if you call it a revolution, but of course we want to focus also on the speed, because obviously this is important for a lot of processes and going into the industry. That is what matters. And this is something that we also proved with our latest design, with our latest FINEPLACER, the Femto Pro, that we present here at the show. So this is the Femto Pro? Yes, this is the very, very new Femto Pro. Travis, why are you guys so excited about the Femto Pro?
So the Femto Pro is our new system. So it's a faceless based on the Femto 2, which is our precursor, our high accuracy Femto system. But we realized a lot of customers don't necessarily need this 200 or 300 nanometer accuracy. They're more focused on throughput with about a 2 micron range. So we really focused in on that. We optimized the system, we reduced complexity, we improved operator friendliness and also production environment friendliness. So we optimized it to about 50% faster than the Femto 2, while maintaining the full range of modules and production capabilities.
What we are seeing is almost all the semiconductor laser manufacturers in the show already know you, and many of them work with you. But we are seeing a complexity on the manufacturing on next semiconductor photonic devices, photonic integrated circuits, co-packaged optics, you name it. All these companies need to scale up. What kind of challenges are they bringing to you?
So we have a booth over on the optical integration side, and we also see a big growth with quantum coming in. And then, of course, the industry movement towards like AI, co-packaged optics, getting photonics as close as possible to processors and this kind of thing. And yeah, we're just trying to kind of get into that and keep up with the pace of the industry. And when it comes to active versus passive alignments, this is a huge debate. And I think active alignment is always this kind of necessary evil. And everybody tries to avoid it as long as possible just because of the complexity that comes with it. So we try to kind of understand that balance that customers have to walk and meet their passive alignment requirements.
Active and passive alignment are really clear technologies, but of course it's also the gripping of the components. You have more and more components to be placed. Do you have new technologies for gripping, for the handling, for the pick and place?
Yes, of course we do. So we have the fixed tools, which is the classic Finetech tool principle. We've also developed changeable tool tips, and these can be from single photon emitters like VCSELs to single photon detectors like APDs. We can pick from blue tape. We have the handling modules that are also vacuum-based, but we have clamping-based handling modules as well. And then here we can see inside the machine our new ultrasonic arms. So what we see in the industry is this kind of requirement for high-speed VCSEL and photodiode attach. And we've seen this in like LiDAR applications, some transceiver applications. With our ultrasonic die attach, it's one of the faster die attach processes you have because it happens in a fraction of a second. And we can achieve about sub 4 micron accuracy with single VCSELs or photodiodes.
Melanie, when we meet again in a couple of years, what kind of things are going to be new? Let's play the crystal ball game. What is your preferred future for Finetech?
My preferred picture would be to stand for latest technologies, always be on top what's going on in the future. Things that we develop with our customers today or tomorrow will be the products of the future. And I think this is very, very exciting. We will work on the topic of speed, definitely. And I think there are a lot of things to come. And I'm really excited about that.
Finetech, you can do passive alignment with very, very high resolution and now at faster speeds.